Here's some quick examples to help if you have more questions about factoring. So when we have a quadratic in the form of x squared plus bx plus c, when c is positive, then we get these two factors, all right? X plus p and x plus q, all right? And the key here is that these two numbers p and q, they have to multiply. P times q has to be c, and p plus q has to be b. And so p is, c is positive. Basically, they all have the same sign, okay? They have the same sign. They're all positive, all right? So here's the idea. When we're factoring, we need to pull this apart, and we need to find two numbers that add to 10 and multiply to 16. Okay, so think through the numbers that multiply to 16. What makes 16? 1 and 16, 2 and 8, 4 and 4. Well, which ones of those add to 10? Well, the answer is 2 and 8. And if you think about the game we played in class, this is the b value. Okay, these have to add to 10 and multiply to 16. Okay. How about this? We need two numbers that add to 9 and multiply to 14. Okay. So, well, think of the numbers that multiply to 14. And you can list them out. 1 and 14. Okay, 1 times 14. And 2 times 7. Well, which ones of those add to 9? It's the 2 and the 7. And this is actually not going to be x, it's going to be an a. Same idea, but just a different variable. Okay? Two numbers that add to the middle number, add to the b value, and multiply to the last one. Add to 11 and multiply to 18, just like the game. Well, what are they? Think about the products of 18. 1 times 18 makes 18, and 2 times 9. So which ones add to 11? Well, 2 and 9 are their numbers. Okay, so r plus 2, r plus 9. What adds to negative 7 and multiplies to 10? All right. Well, now a little twist here. What multiplies to 10? Well, 2 and 5, 2 times 5, and 1 times 10. And we've got a b variable here. Well, let's see. Which ones add to 7? Well, not the 10, but these do, 2 and 5. The problem is, this is a negative 7. We need two things that add to negative 7. Well, what adds to negative 7? If we have a negative 2 and a negative 5, that adds to negative 7. And check it out. If these are both negative, then they multiply to positive 10. Okay, so if we have a positive number at the end, then we know that these two numbers in our factor will have the same sign. Got to have the same sign if we end with a positive number. All right, what multiplies to make 12? 1 times 12, 2 times 6, and 3 times 4. Well, which ones of those add to 8? Not 12 and 1, not 3 and 4, but 2 and 6. So we know our numbers are 2 and 6. Now, this is a minus 8, though. So these need to be a negative 2 and a negative 6. That will add to negative 8. Get the idea? What if the numbers multiply to 27? We have 1 and 27, 3 and 9, and I think that's it. So we start with x and x. Which one of these add to negative 12? Well, 3 and 9 add to positive 12, but if we make those negative, then we have negative 12. So minus 9 and minus 3. And by the way, those can be in any order. All right? So that's the idea. When the C value is positive, all right, then we know we got to have the same sign. Continuing on page 125 there, if we have x squared plus bx plus c, and c is negative, well, if c is negative, that means we got two numbers that multiply to c, and so we can factor it. Again, p times q has to be equal to c, so these two numbers have to multiply to c, and they have to add to the b value, just like in the game we played. So when c is negative, then p and q have to have different signs. That's the key. How do we multiply to make a negative number? We multiply when we have different signs. All right? So we want to factor this guy here. Let's look at these examples here. Okay? So we're factoring. All right? We know we need to multiply to negative 21. Well, what multiplies to 21? 1 and 21, 3 and 7, and that's it. Now, we'll think about the signs here in a second. We want them to add to 4. Well, add, I'm going to put this, or subtract. Adding and subtracting are the same, just with negative numbers. So which one of these add or subtract to 4? Well, not 1 and 21. Those, if you add them or subtract them, 21 minus 1, no. 21 plus 1, no. Okay, they're not going to make 4. But these are your numbers here. So we're going to have x and x, a 3 and a 4. 3 and a 7, sorry. Now, we need to think about this. Is this negative 7 and positive 3? Do those add to 4? Nope, they don't add to 4. They add to negative 4. Negative 7 plus 3 is negative 4. Okay? Well, what if we change the signs? Now we're talking positive 7 plus negative 3 is positive 4. We got it. That's our answer. Okay? How about this one? What numbers multiply to make 8? Just kind of list them out for yourself. 1 times 8, 2 times 4. Those are the only ways to make 8. All right? So we have R and R. We're going to start that way. Now, we need to add or subtract, okay? So we need to add to 7. Which one of these add to 7? Which ones will make 7? Can you make 7 out of 2 and 4? 2 plus 4? No. 2 minus 4? No. 4 minus 2? No. 4 and 2 are not going to add or subtract to 7. Okay? What about 1 and 8? Those will make 7, right? There's our numbers. So we know 1 and 8 are the numbers. Now, we've got to decide. Is it a negative 8 and a positive 1? Well, if you add those, you'll get negative 7. We don't want to have negative 7. We have positive 7. So let's fix that. We want the 8 to be positive and the 1 to be negative. If you multiply this out, you'll get what you started with. Okay? So hopefully we're seeing it there. All right? Again, we've got to have opposite signs. So we have Q in this case, we're going to start with. What makes 9? 1 and 9. 1 times 9, or 3 times 3. Which one of those add or subtract to make 8? Not the 3. 3 and 3 make 6, or 0 when you subtract them. But 1 and 9, those add or subtract to 8, right? 9 minus 1. So we want a positive 9 minus 1. That makes 8. Okay, so these add to 8, and they multiply to negative 9. All right? That's it. So we're breaking it up. We know because it's a 1 in front, an invisible 1, these are going to be the same. We look for the numbers that multiply. 1 times 18, 2 times 9, 3 times 6. And we ask ourselves, which of these pairs add or subtract to 3? Not this one. 2 and 9, does that add to 3 or subtract to 3? No. But 3 and 6, they can subtract to make 3, right? How can you use 3 and 6 to make 3? How about positive 6 minus 3? And there it is, positive 6 minus 3. That's our answers. So factored form right there. Start with the products, and then check to see which ones add or subtract. What makes 18? 1 times 18, 2 times 9, 3 times 6. Okay. Well, which ones add or subtract to make negative 7? Not this one. Not 3 and 6. 3 plus 6 is 9. 6 minus 3 is 3. But 2 and 9 can make 7, right? Okay, so we have negative 9 plus 2, right? That's how we make 7. With addition, we make it with a negative 9 plus 2. There it is. So we're setting up this framework with the parentheses. We know because it's 1n squared, it's going to be n times n. We know the last numbers have to multiply to make 12 in this case. 1 times 12, 2 times 6, 3 times 4. And we know that they have to add to make 4. Which one of these add to make 4 or subtract? Not this one. 12 and 1 can make 13 or 11. 3 and 4 can make 7 or 1 if we subtract them. 2 and 6, if we add and subtract them, can make, well, if we subtract them, we can make 4, right? Now we want to make negative 4. So what can you do with a 2 and 6 to make negative 4? Let's make a negative 6 plus a 2. Or, if you want to think of it as, let's make a 2 minus 6. Right? That makes this. Okay. So we're going to have a positive 2 and a minus 6. There's our numbers. That's it. All right. That's how we factor. If C is negative, then they're going to be a different sign. So just think we check by adding or subtracting. All right. So look for all the factors of C, and then decide which ones to use by checking to see what they add to. All right. Okay. That's it. Hope that helps.